Welcome back. Chris Tinker, Distinguished Technologist at HPE, is a leader in bringing solutions to enterprise customers, not only through innovation and development, but also through true partnerships with other technology providers, as well as with customers. We are honored to have Chris with us to offer some insight into what is driving the digital transformation and why Hewlett Packard Enterprise is at the center of it. Welcome, Chris.
Thank you, Ruby. Guys, I want to talk to you today about the Intelligent Data Platform. It's around the software-defined data center and mapping the art of the possible. Software-defined has a lot of elements. It comes down to workload optimization. It comes down to, if you're looking at workload optimized, how is it intelligent? How are the various KPIs brought back to operations? And how does operations simplify their delivery of those IT services to the business, generating a cloud experience? How does that actually happen? So let's just map it out right quick. So in your data center, you're in various parts of this journey. As any corporation out there, I mean, standardization, 10 years ago, we all did standardization. So of course, I'm going to assume that that's already been locked, stock, and barrel. But how about orchestration or automation? The elements of robotic process automation, that using the intelligence from the various technologies, those insights into a decision engine. And how does that decision engine actually roll out into creating a cloud experience? Now, there's not a simple unicorn solution that solves all problems. That's why we need to look at what are the business requirements for workload optimization. Are you needing a transactional scale-out architecture? In transactional, is it general purpose? When I say scale out, are we talking about 10 VMs or 10,000 VMs? Are we talking about particular transactional database workloads? Are we talking about new age, maybe Elasticsearch or various capabilities of AI and ML? We'll get into that in a little bit. And at the end of the day, we're talking about that transformation that's actually taking place and occurring with the advent of cloud automation. When I'm talking about cloud, I'm really talking about creating that self-service catalog, creating that experience that actually, if you think about a public cloud experience inside the data center, to achieve a particular aspect of predictable performance, reliability of data availability, maybe you're looking at certain aspects of compliance, regulatory commitments. How do we solve for these various degrees of complexity? More importantly, how do we make it simple? So hopefully in the next hour, I'll be covering all these topics here, and you'll see exactly where these technologies fall in. Well, it comes back down to what is the HPE strategy? Our strategy is quite simple. It's to make IT simple, the hybrid IT simple, have the strength to make it simple, and then how do we empower the intelligent edge? Various technologies, various customers out there are looking at ways that they're augmenting their edge. Whether it be the vertical of healthcare, maybe it's manufacturing. In any of these verticals, if it's in telecommunications, the edge is changing. Where sometimes the edge is essentially today's data center could be your edge today because of edge capabilities of large-scale data analytics, where traditionally the edge would have very little data. Today, edge could have 10,000 compute nodes. In a certain corporation, certain verticals, certain industries, this is their edge. So how do we solve for these various complexities? Well, it comes down to a couple of key elements. How do we create a simplification of the delivery of those services? How do we make it where it's consumable, that cloud experience that I just talked about? And then how do we do software-defined in these elements? How do we do software-defined as an implementation of scale out, agility, flexibility? Maybe it's lifecycle management as you look at the lifespan of these technologies. The data, the assets, the actual ecosystem that actually is growing over time, you wish to be able to take advantage of newer technologies, inserting those new technologies into the ecosystem without disrupting the user experience. Well, I wish I could say that it's all simple. We, in our collaborative product development organization, work with our ISVs to simplify this map. This is not everything, of course. If you're talking about robotic process automation, or maybe you're looking at artificial intelligence and how to actually do the entire install base, take that install base, funnel that telemetry data back into an ecosystem that actually allows us to create predictive analysis back to our consumers, our customers. How do we do all this? Well, it comes down to a vision, and the vision is around the intelligent data platform. It's not a product. It's a means by which we leverage technologies to deliver an AI analytic platform to all of our technologies. Self-managing, self-healing, predictive. These are words, but these words have tangible meaning, and we can deliver on it today. How do we deliver on it today? Well, let's get into that. So, I guess the first thing is looking at software-defined POV. If you think about a software-defined POV, I'm thinking around, it comes down to 3 key elements. Is it workload optimized? So we take the business requirements, map that to a workload characteristic. So we need a workload optimized solution. We need an intelligent engine that actually keeps us the ability to do that predictive and self-managing and self-healing, all that stuff I just talked about a moment ago. How do we do that? Where is the machine learning? Where's the AI that actually feeds that? And then how do we actually take action based on that intelligence? It's not enough just to say, you've got a red blinky, a red blinking light, or we want to be able to stop the fire drills. How do we do that? We'll get into that in a minute. And then lastly, consume it as a service. Create a cloud experience. Nobody wants that actually complexity of having to actually go and piecemeal this stuff together and put it all together themselves. They wish to be able to consume it as a cloud experience. That goes through the procurement, the delivery, the supply chain, putting it into the ecosystem with a very simple means of bringing a solution to a business problem. Well, what you see here is a map. It's the map of the possibility of what workloads can be brought to bear on a particular solution. Now, this map is not intended for you to walk away and go, oh my gosh, I can now, this is so complex. It's not that. We leverage this technology map to work with our field and our partners and our channel to enable them to have more meaningful dialogue, to understand what are the business requirements, what are the outcomes being sought, what are the particular challenges that exist today in that ecosystem that talks about perhaps it's transactional workloads I mentioned earlier. Perhaps it's being able to scale up a massive mail client system to 1 million users. How do we go about solving for these various industry-specific workloads and create a software-defined ecosystem that actually delivers on it? Well, if you think about the actual map here, I'm breaking it into actual columns. And these columns explain and elaborate some of the Paretos that evolve the 80-20, if you will. On the left-hand side here, block store, as you see elegantly managed there, is block. Block is for workloads that are characterized by transactional behaviors, databases. Transactional workloads that require or susceptible to low latency behavior. In the industry where as you've heard from today, you've heard from our partners like Mellanox and Cumulus and the plumbing aspect of it, right? That's the network. Customers are starting to pivot to Ethernet fabrics of 50, 100, 200 gig networks. And in 100 gig, they're leveraging certain technologies that didn't exist 5 years ago, 2 years ago, with being able to do not only just Rocky, but being able to do NVMe over fabric. Converged fabric. Maybe it's NVMe and being able to use client-based NVMe, client-based protocols that actually do block aware to the actual backing store. So that's highly performant, transactional. But in the same respect, we want to be able to actually work with particular aspects of the optimization and capacity management and utilization of the assets. Not everything is going to be running at NVMe speed. Some of it's going to be running at, well, I'll call it density optimized capacity. Density optimized, where you're leveraging particular aspects of NVMe and SSD. Is it read optimized, write optimized? Is it mixed use? All the way down to spinning disk. Complexities that do exist, we need technology that actually is able to take the telemetry, the workload, and a policy so that a workload, an application, a business can identify the tagging of the asset and understanding how that asset, workload, business characteristics should consume the services. Should it be performant? What are the reliability aspects of it? Corporations today are leveraging traditional landscapes. When I say traditional block, everybody understands RAID. RAID 5, RAID 6. But what about the density of material today, density of media of 16 terabyte SSDs or 32, 64? We have labs at 128. The question becomes, how are we actually figuring out how to do the rebuilds and how to actually optimize the workloads? Is RAID the requirement? Not to kick RAID. RAID's a phenomenal technology around a durability characteristic, but there's other ways. There's other ways of creating an ecosystem of when you start scaling up to deliver an outcome that is rack resilient, where customers' business cases no longer can sustain the outage of a particular rack or a particular fault domain. The fault domain must scale rows and racks and various forms of durability. This is where we need to leverage other things, like replica copies. Replica copies allow us to do certain things with block that achieves a transactional performance. This is found in a lot of your object storage. It's found in various forms. It's also one of the key aspects to Datera. We'll get to that in a minute. But if you think about those key characteristics of block, transactional workloads, how does HP bring it all together? Well, a couple of ways here. If I were to look at this, we actually look at cloud management platform partnerships. We look at secondary storage partnerships, primary workloads, and of course the intelligent data platform. So I will start with the intelligent data platform. And if I think about that, our intelligent data platform, again, looks at the particular workloads, as you see articulated here, application workloads. Then, of course, big data workloads. Big data, whether it be AI, machine learning, or various capabilities of leveraging certain aspects of streaming analytics with Kafka. Being able to actually figure out how to place the data into the ecosystem and how to absolutely be able to manage the data, manage the ecosystem, and provide the business the means by which they can consume not only the infrastructure, but be able to actually facilitate the consumption of IT resources at a utilization rate of 80% and sustained 80% without injecting risk to the business. This has been very challenging to do previously, where, I go back to a CapEx model where people would just buy what they need or what they thought they needed and then consume the assets at 20, 30, 40%, and figuring out that, yes, we have stranded capacity. Stranded capacity gets into situations where in the storage world, this goes into capabilities of where you have gargantuous amounts of capacity, but the performance has been exhausted. You've exhausted the memory lanes, the CPU memory lanes, the weight channels inside the actual ecosystem has been exhausted. Therefore, you have wasted capacity. You have unrealized utilization of SSDs or NVMe or any of these actual aspects. So the key here is being able to take that KPI, the telemetry data, and bring it up into an operational dashboard that allows us to be able to facilitate data placement, workload placement. This is all about the intelligent data platform. How do we do this? Well, the intelligent data platform is a key aspect of InfoSight. InfoSight is an engine of HP. It's an analytic engine that works with our products. One of the products in particular, our server portfolio. Now, I have it down here, but again, mission critical or general purpose, these are workloads that allow us to actually start looking at predictive analytics. Maybe it's the interoperability of particular known drivers where the install base has had a problem with a particular driver and a version of that driver with a software stack that caused a business outage or a business risk or some type of durability challenge. But now we can inoculate the rest of the install base, notifying them, we have a challenge here and we're going to solve this for you, making sure that you are not susceptible. So, whether it be a predictive analytics, maybe it's workload fingerprinting, where we're taking a look at various workload characteristics that are in the install base, understanding what those workloads are, and being able to, impose particular predictive capabilities of performance saturation so that we can get into sizing tools. So we can predictively size solutions. More importantly, if I look at it from a cloud consumption model where I just said that we're going to utilize the assets at 80% utilization, we have to be able to predict that workload with this infrastructure, with this configuration of durability, RAID, replica, eraser, maybe it's snaps, maybe it's replication, whatever the actual capabilities are, knowing what those workloads are, what their theoretical maximums are, and then being able to say, we can actually say that that workload in the install base is going to consume and exhaust those resources at this particular bar, then providing the operations, providing the business the ability to make business decisions faster, accelerating the time to value, mitigating risk, mitigating disruption. So again, this is all global learning. I have it right here, global learning. It's the install base I just alluded to. And of course, the recommendation engine. But a recommendation engine itself has a particular characteristic. It's a recommendation. The recommendation available via an API to a decision engine that actually can take action now as a completely different aspect of robotic process automation. How do we do this? Well, let's get into that in a moment. So let's just go back right quick. So we've checkmarked on the actual intelligent data platform. This is the machine learning, the AI. This is a monster Elasticsearch engine. It's Elasticsearch, it's Elk, it's Kafka, Kibana, it's all of it. Looking at the entire install base, and we have data scientists aiming at focusing on these characteristics. And we're working with our partners, our ISV partners, our software partners, to incorporate API mechanics and API connection tissue that allows these technologies to correlate events. We do this with VMware. We do this with other technologies. And we have acquisitions that we've actually done this with. So where to next? So I'm going to talk real quick about looking at how that actually maps back into a block store. So we talked about intelligent data. That's actually the analytics. So where are we at on Block Store? So I'll click on Block Store. HP's portfolio is comprised of workload optimized solutions. So customers come to us and say, look, my strategy is to address a scale-out, performant block ecosystem. I need general purpose. I need a certain amount of capacity. I need a fault domain that is rack resilient. I need low latency. These are certain characteristics that can no longer be achieved with a system-defined characteristic, a system-defined deployment. We have to be able to leverage best-in-class compute nodes. Our secure servers, the DL380s, the DL360s, we have a large portfolio of infrastructure. The question becomes, how can we create reference configs, reference architectures, create package models to deliver the the time to value, the speed to action, collapse that so that the market, the businesses can take advantage of these new technologies. Enterprise class performant. That brings us over here to Datera. Datera is a software-defined, runs on our x86 platforms, can take advantage of NVMe and SSD. How does it look? Well, if you just click on it here, what we'll see is a particular aspect of providing iSCSI block services, but more importantly, a policy engine that facilitates NVMe, SSD, spinning disk. And these are capacity optimized, workload optimized configurations, but more importantly, you can take these nodes and inject them into the actual namespace and grow it, scale out. And you can scale out based on your workloads and based on your configurations. You can actually achieve a simplified ecosystem made up of density optimized compute nodes. These are providing data services, storage data services to your compute. So we have a lot of customers in the various industries that are asking us for this type of capability. More importantly, looking at new questions around creating more durability. 14 nines of availability. We won't get into the nines. What we'll talk about is, how do I do replica? 2 copies, 3 copies, 4 copies. They want to take rack nodes down. How do we actually achieve the actual durability of services without disrupting the business? Datera gives us that capability with the block. It facilitates a couple of other key characteristics. The policy engine that I alluded to earlier. The policy can be applied to the various media types, whether it be read optimized, write optimized, just name your favorite. The idea is making sure that we can create a cloud experience. You have a cloud controller that actually you can deploy in your ecosystem that actually has a policy. Now these policies could be deployed with, Kubernetes or Chef, Ansible, Puppet, or it doesn't really matter right now. The key here is we actually have reference configs, we have recipes, we have workflows that actually can deploy any of this, whether we're running on VMware, OpenStack, Kubernetes, Docker, doesn't matter. The key here is making sure that we deliver a business value to our customers in a timely fashion. We have solutions that are already mapped this out, whether you're running bare metal, VM, or containers. All right, so this is Datera in a nutshell. One of the other key characteristics of Datera is our customers will come to us looking at 100 gig networks. But if you're using a 100 gig network, chances are you're wanting to use newer technologies like BGP. Datera supports a BGP peer methodology, so the client can connect directly to a BGP peer. The node of the node controller can become a peer. What does this provide? Crazy low latency. But you need this low latency for NVMe. So as these newer technologies are going into the market, how do we take advantage of these low latencies? How do we take advantage of all these characteristics that are only delivered in NVDIMM technology or an NVMe media for SSDs? How do we do this? Datera gives us a path to that, and more importantly, as our technologies shift, the servers, Gen 10, Gen 11's coming, how do we actually take lifecycle management and take these new technologies and interject it into the actual namespace without disrupting services? Datera gives us that capability. So let's go back here. That's Datera for block software defined. Now, what does it run on? I mentioned Intel, DLs. Here is our Intel portfolio on DL servers, DL360, DL380. This is what we use for our Datera solution that leverages NVDIMMs. These NVDIMMs give us that capability of massive performance, massive durability, but more importantly, not just performance, predictable performance. Predictable performance based on the insights that we're getting from our analytic engines. So that gives us Datera. The next question becomes, what about other use cases, other workloads? Hyperconverged, file, object. Today, I believe Scality's actually had a conversation with everybody. In HP's portfolio, we actually use object storage or deliver object storage via a Scality. Scality, same thing, but the key here is look at this technology. It is a software-defined object service that provides S3 methodology. But if I look at it from a block to object, completely different workloads. If a block workload is transactional or characterized as a transactional workload, then what is an object? An object is for various workloads that need application throughput. Maybe it's a monster mail provider, or perhaps it's a, think about the industry of CME, Communications, Media, and Entertainment. How do we stream videos? Streaming of videos requires a HTTP with secure and all that good stuff, but it's actually taking a get or a put. But being able to get a particular video asset in certain megabyte chunks and string that data across a particular network. Where's the landing zone? What is the actual sustaining, durable, performant, predictable performant namespace? Scality is an object store that facilitates this at massive scale. You know, the sweet spot I give you right here is 500 terabytes, but we have deployments of 10, 50, 100 petabytes. So again, these are various workloads. But again, the workload here, the workload optimization deals with Scality runs on our particular density optimized servers. This is the Apollo product lines. Apollo is a density optimized compute. If I show you a graphic right quick, I'll click over here to Apollo. These are some ideas. But this is a particular platform that just simply loads up the capacity density to deliver a particular software-defined experience to object services. You know what? I will jump back here to Datera because Datera also offers object. We call it performant object. Whereas a Scality is a single namespace that can scale to hundreds of petabytes in a single namespace, Datera is not for that workload. They don't have a scale-out namespace for the actual object presentation, but they do have the capability of certain workloads that require 20, 100, 200 terabyte of performant objects. There are particular applications out there that need this. I mean, just one such thing is like Vertica. There are particular applications that do need this type of namespace. Does your application need performant object? What is the scale? What is the actual concurrency, the parallel access patterns? Is it 5 accesses, or is it 10,000, 100,000, 1 million concurrent accesses? These are the questions we have to ask ourselves to figure out what is the appropriate technology. That's the reason this map exists. There's not a unicorn. Not one thing's going to solve all problems. It's understanding what the business requirements are, what the workload requirements are, what the application requirements are. Then we can figure out what the best technology is. And HPE works with our collaborative product development organization to facilitate in-house technology as well as partner technology, and taking the best of our technology stacks, bringing it together and creating an enterprise quality solution for our customers that actually we can stand behind and support for the long haul. So, if I map this into other workloads, perhaps software-defined, and I don't know if anybody's caught this yet, but the dotted line represents software-defined. That's why I have it here. Look at secondary storage workloads. The dotted line represents software-defined. There's a lot of software-defined ecosystems. If I click on MapR here, we'll see that this is the big data landscape. Perhaps you're looking at containerization of your big data assets. Big data configuration, where you're having applications that actually leverage that workload and want to be able to touch that workload. Blue data is nothing more than a containerization of the big data apps that actually consume the actual workload under the hood. Those same servers I just mentioned with the Datera solution or the Scality solution, those solutions, servers are also the backing store for these solutions. Whether you're running Cloudera, Hadoop, whether you're running MapR, these are technologies that essentially embrace these workload optimizations, solutions and servers, more importantly, the actual plumbing that actually facilitates this, and then taking that technology, the entire MapR or Cloudera, taking that and being able to plumb that into our InfoSight ecosystem, InfoSight AI engine, to allow us to create more a predictive, self-heaving, self-managing ecosystem, taking that intelligence and plumbing it via API to a control plane. All right, so what does that look like? So I've already given you a block ecosystem. We've talked about the intelligent data. We've talked about object stores. In our hyper-converged ecosystem, we can talk about SimpliVity. Now, SimpliVity is our software-defined, hyper-converged ecosystem. It's for VDI. It's for regional office, branch office, line of business VDI solutions. So, why SimpliVity versus Datera? I get to ask this question a lot. I mean, we have Datera in our portfolio, and we have SimpliVity in our portfolio. Well, SimpliVity is a hyper-converged ecosystem. Hyper-converged, one of the key characteristics of hyper-converged is usually the backing store for these facilities. Backing stores that are actually using particular aspects of eraser-coded Reed-Solomon ecosystems and algorithms to actually create an instantiated namespace. That means that they're not transactional oriented. They are throughput oriented. They're VDI. They're light I/O workloads. There is a reason that one solution can't solve all problems. We have to be able to understand what is the characteristic that you're needing to solve for. If it is a VDI workload, then SimpliVity is a good choice. It's phenomenal assets. It does data protection, does all this, and guess what? It still runs on the same ecosystem. I mentioned a moment ago about the servers, the DL380s, the Mellanox switches, the Cumulus networks, the Arubas. It runs on our networking. The key here is understanding that SimpliVity is a software-defined hyper-converged solution. At the same respect, where does Datera fit? Well, Datera, right here, block. Transactional workloads. So if I wanted to run a SimpliVity namespace with VDI, and I also wanted to instantiate a Oracle RAC database, got to ask yourself that question. Oracle RAC, is it 10 IOs a second? Is it 1 million IOs a second? Of course, IO size matters. But at the end of the day, it's these type of questions we have to understand. What is the dissemination? What is the Pareto of the applications and the workload and the scale of those workloads? What are the other business requirements around agility and durability? Once we understand these questions, then we can assess what swim lane do we need to be in? What technology do we need to actually look at to solve these business problems? So we've talked about block with Datera. We've talked about hyper-converged with SimpliVity. Why don't we talk about, whether it be, let's look at file. If I look at file has key characteristics. One of the key characteristics of file, and I'll just give you a landscape here. This is the landscape of file from Hewlett Packard Enterprise. Store Easy is a software-defined Microsoft solution that provides a software-defined file, SMB, NFS, but again, it's focused on Windows environments. Basic NAS. You also have 3-par file persona. This is a converged ecosystem where we take an enterprise primary array from HP and put it together. Now, at the same respect, we also have Cumulo. Cumulo is a software-defined scale-out NAS. What does it do? It's a solution that is optimized for particular aspects of massively scaled file. Its primary use cases are video surveillance, PACS archives, anywhere where you need massive file resources to do file analytics. One of the key aspects of Cumulo is the fact that it can handle billions of files and do all the analytics against those billions of files and tell you all the telemetry about who's accessing it, what it is, how long it's been there, all the actual business requirements that you need to understand how is the assets, the infrastructure being used, how is it being utilized by the business, but also being able to provide that telemetry back to the business on how their data is consuming those resources. It's important. A lot of, right now, CIOs, CEOs are asking, we got 1 billion files. When was the last time that 80% of them were touched? What are we doing with them? Now, of course, there's regulatory commitments, regulatory compliance that, maybe some auditing, you need to have it for your life. The question becomes, how do we manage the assets of where it is? How do we actually understand that files that are 6 months, a year, 2 years old, and using an all-flash ecosystem, why don't we age that down to something else? How do we do that? How do we do data management? We talked about lifecycle management earlier, about infrastructure, where these solutions can take advantage of density server optimized solutions and then be able to have the granularity of being able to implement various new technologies into the namespace. But what if we bring it up a layer and understand how to actually do the data management itself? So Cumulo is a software-defined scale-out file. Datera, block, Cumulo's file. So why is that different? Well, files have particular characteristics of file operations. Opportunistic locking. Opportunistic locking deals with the concurrency of users. Think about group shares. So there are key characteristics of workloads, whether it be an application-based access to that file or whether it be group shares, users accessing of files. But we have to be able to maintain the level of concurrency and the file operations against these particular file directories. And when looking at certain things like directory name lookup caches and other aspects, these deal with performance. Cumulo is a scale-out solution. Store Easy is a scale-up solution. 3-par file persona, again, not software-defined per se. It's software-defined control, system-defined deploy. So if you think about 3-par there, that's where it fits. I'm just trying to explain why we look at certain characteristics. Scality, I mentioned a moment ago, is an object store. It provides a massively scaled object namespace, runs on density-optimized servers. We have that telemetry I mentioned a moment ago about taking the servers, plumbing that into InfoSight. InfoSight takes the analytics, gives us the capability of doing predictive analytics. But if I bring it back to Scality is a software-defined solution that provides me object services to the clients. How does it do file? It's not a NAS. It does not do opportunistic locking. It would be very bad and horrible for group shares. But what is it great at? What if your application, the application actually provided out the actual NAS capabilities to the client, and the application needed to be able to access the backing store via an SMB or NFS protocol? Scality was phenomenal for these type of use cases. Maybe you're doing video archive. Maybe you're doing video analytics, where the analytics of the application is actually the one doing the conversion into an object protocol or a file protocol. Again, the application is doing the opportunistic locking. So it's these kind of data paths that we have to look at. What is the use case? What are we trying to do? Perhaps you could have, for example, you could have a huge library of video assets, and you're wanting to be able to take an application and do some heuristics and data analysis against those videos, but the application needed file access. The application cannot work with an object. The application is not modernized. It cannot do an object protocol access, but it can do a file access. The application does all the locking and all the data management. Scality could be your solution. Weka is a slightly different ecosystem. Let's pivot to the other end of that spectrum. Weka is a highly performant file namespace. Again, these are workload-specific use cases. Where Weka shines on very small files, millions of files, but massive performance. Where you have solutions that have NVMe solutions on like a DL360 with 10 NVMe and 200 gig networks. You're needing 200 gigabit, somewhere near the neighborhood of 17 gigabyte per second per node. That's not everybody. But if you're actually having a GPU workload where you're actually doing data analytics and leveraging GPUs and NVIDIA to actually facilitate particular data analytics and AI workloads and AI models, then Weka could be your choice. Has a couple of key characteristics. Where does it fit in our portfolio? It leverages its own hierarchical storage capability, being able to leverage NVMe burst buffers to an object store. That's why we have reference architectures here to explain this. So it provides file, and it provides data management. But again, it's really focused on high performance. So if you have GPU needs, this could be your best friend here. Datera. Datera is another solution, software-defined, runs Datera. It's at the edge. It's an edge NAS it's an edge NAS filer. The nice thing about Datera is its capability of being able to do NAS filers at the edge and do data optimization back to the core. Again, it's file. These are some use cases for it. You can see I have it here with the Datera drives and what have you. The key here, though, is being able to create this ecosystem where we do edge file serving and then bringing that back to the core. This is how Datera works. So bringing this full circle, I've covered file, we've covered hyperconverged, we've covered block, we've covered intelligent data platform. I have essentially covered MapR in the Cloudera ecosystem and Splunk. These are ISV partners of HP that leverage our ecosystem, our infrastructure, and our reference architectures. The key here is being able to understand what those workloads are. I mentioned again. And if it's edge IoT, it's the same concept. If your edge is needing highly performant block scale-out architectures, a block capability of being able to snap directly to an object, but you maintain rack resiliency, then we're going to go with Datera. I encourage you to have these conversations with your channel partners, with your HP representative, and with our partners, ISV partners, to have those conversations around what are your business requirements? What are your application requirements? And how can we actually bring this full circle? So, you know what? We've talked a lot about primary workloads. I talked about the Datera for a transactional block. That's, again, primary workload, performant workload, predictable performance. Well, what about backups? What about secondary storage? Maybe it's archives. Is there software defined in that landscape? Well, there is. There is. And whether you're looking at various aspects of Commvault, Veeam, Cohesity, Zerto, these are technologies, but they aren't by themselves. We work with Datera to create reference configs, leveraging Zerto. We leverage Cohesity backup ecosystems so that we can integrate seamlessly, non-destructively, leveraging a software-defined ecosystem. What does a software-defined ecosystem look like? Well, without making it too complex here, I've actually drawn a bar over here on the left-hand side. The software-defined really comes into an aspect of the layers of the cake. And how do we do this? So if I were to just show you the art of the possible, this is reality. This is tangible. This is what's going on today, where our customers are figuring out, what do we do for SAP HANA? Well, we have SAP HANA workloads. We have SAP HANA customers. We're the number one on that one. And you can see what we actually do in that space. Well, to the left, we know analytic platforms, whether it be MapR, Hadoop, Vertica. Again, these are just software stacks that run on our ecosystems. We have reference configs for all of this. Maybe you want to actually transform the IT operations and delivery into a cloud experience. Again, workload optimized, intelligent, and deliver it as a cloud experience, consume it as a cloud. How do you do that? Well, it needs modern technologies. These modern technologies can be embraced, provide the telemetry up the stack, more importantly, give me the ability to do robotic process automation. Robotic process automation requires me to actually integrate via API. So with these new technologies, such as Datera, have a full API framework, full API license library, and we leverage that library into our stacks as well. We also work with other partners and control planes, cloud management platforms like Morpheus Data. And you'll see all of them on here with VMware. All these technologies allow us to create better partnerships, to create value that is essentially differentiated in the marketplace. Now, whether it be ServiceNow, whether it be Aruba, any of these technologies that actually map this stuff out. So I'm going to go back into the actual capabilities map, show everybody where the primary workloads, the secondary workloads. We can even break it down to cloud bank. So let me break it out right quick, where we have HP Cloud Volumes. We are working with our partners to figure out how best to do cloud-adjacent workloads. Those cloud-adjacent workloads allow us to facilitate data mobility from on-premise to cloud. And how do we do all this? Well, we do it in various dimensions. We work with Datera, we work with Scality to do cloud adjacent or on-premise cloud. On-premise cloud allows us to move data from the actual data center into maybe Azure or Amazon or name your favorite public cloud. But it's being able to understand where best to place the data and where to consume the compute resources in order to analyze that data and access that data. Well, that takes us down to everything as a service. So if I were to actually just talk about that for a moment, HP has the ability to monitor, operate, administer, and advise. How do we do this? With HP Advisory Services, this is HP Consulting Services, but the advisory services allow us to walk in, do workshops with our partners to ascertain what is the actual business outcome that's being sought, what are the challenges, what are the disruptions that are occurring in that ecosystem to figure out and determine what is the best path to achieve the desired business outcome without disrupting particular workflows and processes and procedures. We have to look at the people, the process, the technology. The people have to be enabled to embrace these technologies. It is change. It is a new way of looking at things. It is a new way of consuming these. So how do we do this? We actually have to figure this out with our customers. We can actually do this in various dimensions. We can do it via, maybe it's just monitoring. Maybe the consumer, the customer loves the idea. They want to go ahead and embrace it, to deploy it, but they wish for HP to go ahead and start monitoring it. Just monitoring and informing them when action needs to be taken. That's one way of doing it. We can operate where it's on-premise, it's deployed. We're monitoring and managing the ecosystem and managing various particular aspects. There's all varying degrees. Maybe it's just firmware deployments, firmware management. Maybe it's being able to understand exactly how to deploy particular aspects of the software-defined ecosystem that is deployed to 1,000 different locations. Perhaps you're running an edge, and your edge, 1,000 locations in retail. Figuring out how to do that software-defined in 1,000 locations could be a daunting task. So how do we minimize that disruption? We work with our partners to create an entire ecosystem to monitor it, advise it, or we can actually operate it and administrate it. So there's various options there. So I'm hoping that you're starting to see the actual lay of the land here. And then finally, consuming it as a service requires us to leverage new ways of taking our partners, our technology partners, wrapping that into a cloud consumption-based model. Something as simple as being able to not look at a CapEx expenditure, not being able to predict, this is what we're going to actually size the solution for, and we're going to deploy in a traditional sense, but we want to take a modern approach where you pay by the SIP. We design it, we have a solution stack that is presented, and we design it where it actually maintains an 80% utilization, providing you burst buffers that you can burst into. More importantly, as you burst into it, the actual system tells you when it is appropriate to start making decisions on growing the ecosystem or shrinking the ecosystem. because it is a cloud experience. And that cloud experience could be to throttle back, it could be to throttle up. The question becomes how. And we have to leverage all the telemetry data, that intelligent data platform that I mentioned earlier, take that data to drive a business value. So I hope that this was a meaningful dialogue for you guys today. And I would like to go ahead and bring up Chris Cummins, CMO of Datera, to have a follow-on conversation around various aspects of workload optimized, intelligent cloud experience solution stacks, especially one we just actually created with Datera.
Great, thanks a lot, Chris. Really appreciate it. Let's break it down though and say, you're out with customers every day too.
Yes.
And they're thinking more broadly about data center modernization. Let's start at that level.
Okay.
What are their what's their immediate focus when they're trying to get this under control, and where they are on their journey towards a modern data approach?
You know, it varies wildly. I do travel a lot around the country talking to our customers and all. You know, the customers who've tried to, you know, maybe they've embraced the public cloud and they're having a repatriation problem. They're trying to bring the data back because they found out that the particular workload was not analyzed and they're consuming too much of the compute, or they're consuming too much of the actual transactional nature of the storage in our ecosystem. And they actually had a better utilization, a better durability, because some of our customers have, well, unfortunately lost data. So they're trying to figure out how can they solve particular business problems. And it's not the boomerang where everything's coming back. It's identifying particular aspects of, here's our strategy, and it's creating a workload optimized, intelligent ecosystem to tackle these problems. And it's where you guys have helped us, especially around customers that are wanting a software-defined, performant, scale-out approach, so that the granulation of scale no longer becomes this hindrance, this challenge. They can actually take these new technologies. When I say new technologies, I'm really talking about the actual storage technology, like the type of media, being able to embrace these advances into the ecosystem, and it allows them to have a better lifecycle management and better utilization of the asset.
Yeah, I think the data that I've seen is most recent from IDC a couple of weeks back, was 85% of large enterprises are repatriating 50% of their applications. And it doesn't mean that they had a bad experience. Maybe those applications were born there. They just weren't meant to live there forever. So when you go and you're talking with these types of customers, and they're thinking not just about what are they doing at the broad data center modernization level, what we're talking about in this whole effort, but they're starting to look at what they're going to do for their next generation architecture for data. What specifically are the requirements that are coming up time and time again that are part of this equation? Because you know, it takes a genius like you to be able to go through all these options to parse what goes where. So what are those requirements?
You know, it's an excellent experience there. If you're talking about, you know, these customers are making these decisions on cloud management platforms, I equate it back to the experience they're getting in the cloud is this telemetry, this new information that the CIOs and CEOs have today they did not have back then. They didn't have in the traditional sense. So they're looking for, how do I create not only the telemetry and business decisions based on telemetry, performance, capacity, but durability, reliability. And a lot of the reasons these guys are coming back to the enterprise is they need predictable performance, sustained reliability, the durability, and the copy data management capabilities. The copy data management capabilities just don't exist in the cloud, where particular regulatory requirements do facilitate these new age requirements that are requiring so many pieces of the data to be in so many locations.
Okay. It seems like those are resonant right now, that when I saw data even from our friends at ESG, when they're looking at adopting software-defined storage, you'd think, well, what would be the number one reason? Would it be cost? Okay, well, that was the case maybe years back, but the recent data that I've seen from them, and I think Mark Peters is going to be sharing with us, is the number one reason is performance, actually. That's why they're going in this direction.
Predictable performance.
And predictable performance is right. So you've been a great partner to us, and in terms of going out there and identifying this need for this kind of capability within this broad portfolio that HPE brings to market. So we're indebted to you. And you were also one of the people that was behind this latest push of announcing a kit that you can get going. And this is the Datera Cloud Kit, which is comprised of HPE, Mellanox, and Datera. So where do you see that playing in the future as we look at this coming year of FY 2020?
You know, it simplifies the decision tree of understanding how can a customer today leverage, you know, if it's software-defined block, that's one thing, but we're talking about how can we take advantage of particular workloads. They want a cloud experience, but they don't want to have to take the time to figure out, okay, what is the best plumbing? What is the best reference architectures? How do I put this stuff together? So what we've done is work with you guys to create a essential configuration that allows them to interject it right into their work streams, right into the workflows. It's a complete solution stack. We'll call it an appliance, but it's really not an appliance, right? Because an appliance does require some hardware anomalies there, but essentially it's a software-defined solution that can easily be adjusted or augmented, but more importantly, the time to value is collapsed. It's easy to simplify the deployment, standing it up, and can start consuming the actual resources to deliver a particular application or deliver a particular services to the business.
Mm-hmm. So it's an on-ramp to the future. It's not a rip and replace necessarily. It's, hey, get started with it and move it. And
how do I augment my portfolio? If I'm a consumer, if I'm a CIO, I'm looking at how can I implement the solution, augmenting my ecosystem without causing massive disruption. This Cloud Kit provides a very elegant, very simple means by which we can deploy, implement, and augment an existing ecosystem.
Awesome. So any parting gems of wisdom before we wrap this up? We are really grateful for you being here and making the trip all this way to participate. So,
well, thank you for having me. And you know, at the end of the day, it comes down to business requirements, workload requirements. Take a look at those. Figure out from there, how do we take the best technology to deliver a business outcome?
Thanks so much, Chris. Really appreciate your time.
Thank you.
All right. Take care.
Well, thank you so much to Chris and Chris. Well, coming up next is our SDDC Virtual Symposium keynote conversation. Mark Peters, Principal Analyst and Practice Director at ESG, will give us his thoughts on the digital transformation towards software-driven infrastructure and some very intriguing data from the latest studies. And Mark will lead a discussion with Guy Churchward, CEO at Datera, and Thomas Sable, Sales Leader, U.S. Storage and Software at Hewlett Packard Enterprise, for a fresh perspective on data-driven IT. It's all coming up 1 p.m. Pacific, 4 p.m. Eastern Time. Be sure to join us.